is Olena, and for quite a long time I've been working with data in all shapes and forms. And I work at the moment at Confluent. And at Confluent, we stream real-time data, we process, we govern, we store. We do a lot of serious stuff with data, such as bank transactions, fraud detection, health institutions. But today, I wanted to do something fun with data. And in this talk, I wanted to combine streaming data and AI with my favorite game, based on the number of hours I played it. Any of you played Stardew Valley? Okay, we have not as many hands raised as I expected. And if you haven't played Stardew Valley, don't. You will save hours and days and months and years of your time. So yes, amazing game. So what I wanted to do today is to take the game characters out of the context, put them on the village square in Stardew Valley, make them talk to each other and experiment with a couple of concepts. And we are going to do this with a couple of technologies. First, we are going to use Apache Kafka. We are going to use Apache Flink. We are going to use an LLM. I selected OpenAI. I also tried other LLMs. OpenAI was kind of better returning the responses, even though that's debatable. And then we are going also to add some vector search and drag for the memory part. But before we jump into that, I wanted to talk generally about agents and a bit of research around the agents, and also to share how I came up with the whole idea and why I started looking into that. Actually, before preparing this presentation, I was like, I want to have some kind of like latest research on the topic. Let me find like some kind of links to latest or exactly on LLMs related to agents. And I found this GitHub repository, and it's just like huge number of latest papers. Then another GitHub repository with some other collection. So there are so many research done in the area, and I'm not going to cover even a small fraction of that, even though I will share those links with you at the end. But what I wanted to mention mainly is that research papers which I think, at least for me, brought a lot of ideas, and also for me felt like they had some kind of innovation relevant to AI agents, especially if we want to use them in some kind of simulations or gamification scenarios, or like some social studies. And it all started, at least for me, a couple of years ago, actually more or less like 2 years ago, when I saw this demo. And that was the guys from Standford and Google. They did a collaboration research paper, and they implemented a village with around 20 villagers. And those villagers, they do have some kind of basic information about them. There are like students, there are like retired people, or all kind of things in the village itself, which they can do. Each of them has their normal schedule, even though they can technically, creatively decide what they want to do instead, if they have reason for that, and they have some preferences and kind of like lifestyle. So all of that information is written, and then with the help of LLM, it's brought together that they talk to each other and they live through, at least in this demo, it was 24 hours, and they have also a goal to achieve. The repository is still there. It hasn't been sadly updated for quite a while, but this is what happens with AI. We move so fast, and then even like amazing things like this gets kind of dropped out. But still a pretty cool research. So how it looks, they have this map. So they have a park, they have houses, they have college dorms, like cafes, and those villagers, they can move around on that map. Usually they have some kind of agenda where they want to be at some certain amount of time, but again, they can change that plan according to whatever is happening around. Every villager will have some morning routine, some kind of approximate schedule. But the interesting part, at least for me, the most interesting part of this particular research and this demo is actually how they worked with perception of these villagers. So the villagers can perceive what is happening around them. For example, they go and wash their hands, or they meet some person, or they overhear some conversation. And that data goes into the memory stream. And from time to time, they actually reflect on their memories, what is happening around them. And those reflections actually build up to their identity. That also helps them to plan what they're going to do next, and then later they act. So, for example, this is a memory stream of, maybe it's Isabella's memory stream, and Isabella interacts with objects around her and then goes around and does certain things. And the creator of the paper, he describes that they are using, because there are so many memories happening, so many events are happening around those agents, that whenever when they retrieve those memories, it's like too much. So they need to retrieve only what is relevant. And at that point of time, when this paper was written, that was 2 years ago, additional challenge which they had is actually that the context windows which we have for LLMs was significantly shorter. Right now, we use RAG still, but we are not so much limited. We don't have to compress so many events. But they actually had the challenge that they had to be very careful what goes to LLM prompt and what is not, because only the most relevant stuff should go there. Otherwise, there is not much space when all those agents live for 24 hours and there is a lot of things happening. So they were using this retrieval score, which is based on recency, importance, and relevance to the current situation in which the villager is. And based on that score, they were deciding what is actually Isabella is thinking and perceiving. So here she says, I'm looking forward to the Valentine's party that I'm planning at Hop's Cafe. The funny situation is, I think that the day they are imitating is in July. I'm not sure how come Valentine's Day happened in July, but that's, I guess, a different reality. But here's, for example, how it is for Klaus Müller. It's the same. So there are some observations and there are some reflections which Klaus is doing based on observation. So, for example, Klaus Müller is reading about gentrification. So this is observation. So, or Klaus Müller is discussing his research with the librarian. This is observation. And then the reflection is Klaus Müller spends many hours reading. And then we go up, and this is kind of the perception of Klaus Müller that he is highly dedicated to research. So those things kind of combine and then pop up the kind of more global ideas to the top. What else they did in this paper, first of all, they tried to interview those characters and perceive if over the time of those 24 hours which they were imitating reality, they stay consistent to their identity, whatever identity those characters have. And they try to interview them later and see if they are still consistent in their behavior or their thinking. But they also put a seed of idea to Isabella, and Isabella was supposed to organize a Valentine party. And then they wanted to see if Isabella will convince other characters to come to that party and also maybe to bring something to the party. And in the end, indeed, some people were bringing some balloons, others were just coming there. So not everyone got that message from Isabella. There were some villagers who actually spread that idea on behalf of Isabella, and also some villagers who never actually got that idea. But in general, Isabella managed to make a party with that seed of knowledge and then no other help of the researchers. The repository, as I mentioned, it's still there. You can check it. It's a lot of code. I also liked how they actually structured the prompts. So a lot of interesting ideas to pick up, and I think it's still quite relevant. And in general, I think that in this paper, which at that point of time was kind of new, we are introduced the concepts of memory, of reflection, chain of thought. And right now, for example, a couple of like last week at the AI Engineer Summit, there was a person who was describing how Gemini evolving, and they were talking about all of this. Gemini is capable of thinking and making these actions, which right now we also see with other models. So we are using chain of thought of that. But in this paper, they didn't have access to those models. It was still GPT 3.5, and they introduced a chain of thought on their own of kind of reflecting and combining those ideas. So I think still this paper was quite amazing. Based on this paper, I did a couple of experiments. I first played with a bit of a mafia game. So if all the characters here have 3, so that they fail fast, but like there can be a lot of characters, and then each represent a player, and they don't know who mafia is. And then one character speaks here. So for example, Olivia told something, and then Vincent is considering. So they reflect on what Olivia told, and this is kind of the whole game goes. So in general, my observation at that point of time, and it was still 3.5 GPT, that whoever starts the game, if Mafia starts the game, Mafia convince others. So it's a bit of kind of, I mean, I think in general, models are built to be very agreeable and helpful. So in this case as well, it was like, if the villager starts the game, then Mafia will lose. If Mafia starts the game, Mafia will win. So that was my conclusion. Then a colleague of mine, Sebastian Blank, he actually created another idea. He created a planet Hippola, where aliens were talking to each other, and they were also kind of interacting, exchanging the memories, and leaving some ideas in the live feed, kind of a Twitter of that planet. And I took that idea, and I was thinking, how about actually if I have those characters and they not meet only once, but they meet multiple times, and we will need to perceive the memory somewhere. And I implemented that idea with PubSub, where PubSub was helping those characters to interact, to change the messages using LLM to generate those messages. Then the data went to Kafka, but at the end of conversation, that data was summarized and stored in a vector search, so that we could use Retrieval-Augmented Generation to retrieve the most relevant memories for the next conversation. So when the next conversation is coming up, then for each of the phrases, we can go and see if there is relevant conversation in the past where those characters can get their memories. And that kind of worked. So I had Nick and Judy were talking to each other. I used that Hippola idea because that when you give that idea of some kind of imaginary planet, LLM is very creative of imagining some flowers and caves, and then they were planning stuff to meet again and again. And indeed, like every conversation was evolving some kind of situation between that Judy and Nick and what they were planning to do. Some more interesting research is the same person who was doing the initial research of that village. So here, June Park, and actually almost the same team. They did another research. They took some human participants, and this is, I think, like maybe half a year ago, maybe a bit more. They took some human participants, and they interviewed them for 2 hours. And based on that, they created their generative agents based on those people. And then they interviewed both the real participant and generated agents, and they compared the answers, and they actually showed that there is some consistency. They used some algorithms there, and I'm not a social scientist, so I don't know, but this the general social survey, Big Five personality inventory, economic games, and so on, they kind of showed that there was quite a lot of similarity, and it would be possible to imitate the answers of the real participants by just talking to generative agents, which was super cool. And this is also kind of goes in directions that we can use AI agents for social behavior experiments. For example, how to improve the situation with some maybe problematic parts of the city, or like how to approach best littering on the streets or something like this. Then there were some other interesting research papers. This particular one is the open-ended world. So here an agent has a kind of a skill library or like that agent is building up, and there is this kind of a feedback loop for improvement where something fails with an error, then that agent learns that something else should be done. So here, for example, that agent is building a house, and then constantly agent improves, learns new skills, and there is a lot of other like tools and kind of things that agent can grow to. Another experiment done with AI Town. This is more or less the whole idea again of the village, of those characters which are moving based on some AI and some kind of descriptions, personalities, and you can join also as an additional person there and participate in the conversations and kind of also interact with those characters. So it's similar to the initial research. Here just like added that possibility to be as a person within that village. Then another team of people, they went and they tried to scale it up. So now we are not talking about 20 agents, we are talking about up to 10,000 agents on in that kind of simulation. And here in this particular one, research with OpenCity, their approach or their kind of or maybe key innovation was to think how they can simulate activity of that amount of people and still be reasonable with the usage of LLM. Because if you try to send requests per agent with those like thousands of agents, that actually will not really scale. So what they did this approach of group and distill prompting. So instead of doing it per each individual person agent, they group agent with similar static traits, and then they have the shared prompts for those agents. And that's why it kind of saves a lot of tokens, which we can send. Then there was also a library from Microsoft, and Microsoft library Tiny Troops, they created some tiny world with tiny persons, and that was for the productivity and business scenarios. So for example, for advertisement or software testing or something else. And the whole idea was that we could bring some agents, we give some descriptions to those agents, and then those agents can brainstorm some ideas and implement or do something together. So for example, create an advertisement for a flat which needs to be rent out and so on. So that was pretty cool. I played also with the library, and it was kind of interesting. Sadly, also not really evolving after that half a year, so we'll see. And finally, a couple of kind of more theoretical research, which I think are related. The memory part, because for agents, we need to have some kind of storage for the memories, and there are different kind of memories, long-term memory or the memory of what is happening in the moment, also to imitate, for example, realistically human behavior. Memory shouldn't be exact. So there are different approaches to the memory, and in this paper they looked at it and kind of tried to create a framework of all related stuff to the memory. And the final one, this is about the chain of thought. And this is also when we try to not to just generate immediately some answer, but we have this process of thinking by the model, so analyzing what is needed, maybe getting additional information from external sources, and then producing the response. And right now, I think that those multimodal chain, like those models which are based on chain of thought, are more popular and kind of more effective, even though they're slower and more expensive. So that's a drawback. So with that, what I wanted to do next is actually to build together a bit of a demo of a village using those technologies which I mentioned. And I was thinking which story to select at first. And I selected Stardew Valley not only because it's a pleasure, and then I could also listen to the soundtrack from Stardew Valley when I'm doing this, like kind of all the memories, and I enjoyed it probably more than playing Stardew Valley, but also because it gives some kind of a storyline, some description of the villagers. For example, here's Louis, and Louis is the mayor of the Pelican Town. And then there is some information relevant to that characters, and for every character, then I could use that information. Later, and this is what I'm working right now also, I want to turn it into more like a social sciences, for example, like imagining that it's not a kind of Pelican Town, but instead maybe it's a district in Berlin. I live in Berlin, and then maybe like to evolve a bit more like local characters and see some other social situations. But this one, like I had that background information. I could also add something like what they love, what they hate, any other information, and also I had from the game, because there are so many people who built on top of Stardew Valley, I had those, are they called sprites, I think? So I could use those and kind of put them on the map almost immediately, instead of like, I'm really bad with drawing. So that was very, very helpful. So at the start, I had a villager with their story, and then I had a world, kind of a map where they're walking. And then on each animation frame, I was triggering the movement of those characters on the map. And it kind of, they started walking. I was super happy because that part didn't take a long time to implement. So they walk. They have some patterns that they walk and they pause. For those of you who played Stardew Valley during the festivals, that's kind of the behaviors they had. So they kind of change. They walk, they stay, they talk to each other. So here I wanted that just like they kind of navigate on the map. Then I was thinking, okay, so I have them walking on the map. What I need to do, I need to, once they approach each other to some distance, I would like to trigger a conversation. And how I did it, I sent all the data, their positions on the map. It goes to Apache Kafka topic. And Apache Kafka topic then collects all the locations. By the way, how many of you are familiar with Apache Kafka? Two hands. Okay, so majority of you know what is Apache Kafka. For those of you who are not familiar with Apache Kafka, it's a distributed event streaming platform. Technically, it's a platform which helps us navigate events across your multiple systems, whether it is microservices, which is probably quite a common use case, or some other systems which you need to connect, and then we stream the data. This is a kind of a near real-time data, and Apache Kafka, you can think of it as a pipe which brings the water, and then when we have more water to bring through, we can make the pipe bigger. When there is less water, we make the pipe smaller. Inside it consists of partitions. So the whole architecture of Apache Kafka is done to make sure that we can have as much data moved through the system as fast as possible, because here we are dealing with all those use cases, for example, for like bank transactions or anything else. So you want the data to go very, very fast. So here, for example, how I send the data, I have the name of the villager, and then I have their position on the map and the timestamp, so that later, actually, if I want, I can replace those events. And now I have all those villagers with their locations, and I need to calculate the distance between them. And for this, I decided to use Apache Flink. How many of you know Apache Flink? Okay, just a couple. Someone was very shy to raise a hand. So Apache Flink is in the heart of this real-time data platforms, and it's used for transforming the data. And this is probably the technology which quite common to use, for example, for fraud detection. And it can ingest both kind of the real-time data, which, for example, for us, it's the movement of those characters on the map, the change of the locations. But also, you can ingest this historical data, which comes from some databases or any other sources. And then it outputs the data to whatever shape or form you need it, like applications, or again to database or to another stream. So in our case, we have, and this is with Flink you can work with SQL, with Python, with Java. This is SQL. I mean, I will not, so, and here we are looking at two villagers. So from all the locations of the villagers which are getting through in our topic, we look at two villagers, and here I try to be smart. So here we are comparing them by name. So name is kind of ideal villager, and we try to take only two different villagers and only like one. So for example, Judy and Louis, like Louis and Judy, we don't need. So it's only this mathematical approach, so that we only compare to one side. And we compare and take that information for every second, and we determine if they're close to each other. So for example, here I looked at 1024 pixels on the map, okay, there is like it's actually square. It will be less a bit, so we determine if they're close enough with that mathematical formula, and if they're close enough, then we send event where a close will be true. If not, this value will be false. And then the data goes to Apache Kafka topic. So then also I try to visualize it on the map a bit. So each of the villagers now has kind of a box around them, so that I see more or less when they are like touching other villagers and should start conversation. And this is how then this looks in the topic. So we have, for example, Judy and Maro. At the moment, they are not close enough for starting the conversation. But every now and then, we have this kind of value equal to true. And then we should start the conversation. And for this, to start conversation, I used a large language model. I tried to use various in the past. So here I used OpenAI. I mean, all of them are pretty good. So, okay, I didn't use Gemini. I used OpenAI. I used some local run models. Every model has kind of a bit of kind of its nature. OpenAI might be a bit too agreeable. That's true, but it's very short. If I asked it to reply only, give me a short answer. So I liked it the most. And here we are producing the message for each of the villagers, and we send it to conversation topic. So again, I'm using here Kafka. And then other villagers, as we are subscribed to that topic, and whenever the messages are coming for that particular villager, they receive those messages and they can reply to the message. I will share the repository code later as well, so you can check it for yourself. So when I did that, they started talking. They started talking quite a lot, and also the prompts were not super well written at that point of time, and I had to add a bit of a cool down between conversations because otherwise they chat and they never really stop. So yeah, and then also I had to abort the conversations if the conversation kind of one character starts the conversation, but at that point of time the other character is already moving from that location. So they sometimes they're not super polite. So sometimes they kind of still talking but already walking away. But then I fixed it. It became a bit better. And then here's the topic with the data from the conversation. For example, here Linus tells Louis that I heard about Penny and Emily expressing sympathy to something. That data I have. So now I had to move and I wanted to improve a bit. For example, I noticed if I have 3 villagers, it can be that, for example, Judy will be talking to Louis will be talking to Emily, and Emily will be talking to Judy. So it kind of like becomes a bit of a strange triangle. And actually, okay, the proper fix would be to create a common conversation, which I still should do. But at that point of time, I'm like, okay, if there are 2 villagers speaking, the third one should never interrupt. So that's why whenever the conversation is about to start, I see if there is available partners to start that conversation. Otherwise, I continue moving and doing whatever you do, agent, not really interrupting the conversation. Then I had to improve some prompts because there was some, like Sebastian said to Sam. So like those parts which LLM tries to add. So this is actually how the prompts, more or less, the current version which I'm using looks like. So I give information about that character, who they are. So this is like your name is this, your background is this, and then you are talking to this character and this is about them. And then I tell them that you need to reply to that other person, keep it short, friendly, in character, and refer to what you learned to the, okay, this will come later to the history. But anyway, so like a shallow small talk, and I try to also tell us that it do not mention your own name, speak as a villager, only give a reply, no explanations or meta comments. So with that, they started talking a bit better. And then I was, okay, so time to add the memory. So they need to remember what they discussed before to continue the conversation. And for this, I used Retrieval-Augmented Generation, which is very common and widespread concept. How many of you tried or used Retrieval-Augmented Generation in the past? Okay, we have quite a lot of hands. So for those of you who never use it, it's actually pretty simple. In a way that we are storing some additional context in a different storage. So for example, here I store the memories in some database, but it can be API. It can be actually just a web page where we are getting the information. And then we retrieve that additional context, and then we send it as a part of a prompt to LLM. And that's generally it. So the question is what kind of storage you have. And here, at least in the past, and I still think it's quite common to use vector search as a storage, where we could, for textual information, search not by exact words, but we transform whatever information you have, you transform it into vectors, into numbers, because for computers it's easier to compare numbers for similarities. And we just take the data, it can be text, it can be image or whatever. We use an embedding model, not LLM, but embedding model, which will transform our text into vectors. And those vectors are like 500, 700 or many more dimensions. And we store that in a vector store. And then whenever you are searching for something, you convert that something, or searching for similar objects, you convert the initial object into a vector using the same embedding model, and then you compare and look for the vectors which are closest to whatever object you're right now looking at. And this is kind of similarity search. It works wonders, very effective. It's not really new. It has been already with us for quite a lot of time, but with LLMs, it's actually been used more and more frequently. The only thing right now, and this is what I was listening yesterday to a talk, and that right now Retrieval-Augmented Generation actually has a bit of a drop in popularity or usage just because the contextual windows which we have are growing, so we can actually add significantly more information there, or actually not Retrieval, but vector search in particular. So we'll see how it goes. Still, the contextual window which we have still is not infinitely big, so we have to be particular what exactly we select. But yeah, so this is what I had till that moment. So for every conversation, now what we do, we use LLM to summarize a conversation, and then we embed that summary and we store that in the memories of each agent. So each agent has their own kind of a table index in OpenSearch, and we can store all the conversations or like summaries for each conversation which that agent did there. And when they initiate or they talk to someone else, they always come back to that storage and see if there is anything relevant, and we add that information into the prompt, like all the conversations. Yeah, so then we have now memories, and then I wanted to include, and this is actually, by the way, how the index looks like. So this was, I don't remember whose memory it was, but maybe it was Judy. And this is the numerical representation of the memory which Judy had. So next step I wanted to include some goal. I was like, okay, so let me try to convince them that they want to organize a conference. So in the instructions for the agent, I added also a goal, and then I added that goal that, for example, that was Jody's. She had a goal to organize a conference and spread that information to all other villagers. And that actually worked. I mean, kind of worked, because with LLM also it's a bit unpredictable all the time. So at first, for example, this is Louis replying to Jody, and Louis just gives too much information, so there is no conversation. So I had to go back and improve the prompts. But in general, Louis was pretty happy to react to that idea of Jody. And Jody, once we had that goal, Jody knew that it's her kind of main goal to bring that idea of conference into the conversation. So whenever even Jody was asked like about her family, she actually replied like, okay, my family is doing good, but you know, I want to organize a conference. And actually here, for example, Louis was even committing to involved into helping organizing the event, or even like talking who could do what. But quickly I realized that the problem with the memories. For example, when Louis shared that information with Maru, the memory which Maru had was too brief. So my summarization of the memory was not efficient enough for Maru later to spread that idea to others. Actually, to be honest, looking back, I want to remove the whole summary. I want to store the complete memory, maybe, or like to store way more information. But at that point of time, I went and I improved the prompt that during the summarization, I want to have way more details. And especially if there is about events or something else, we want to have significantly more information stored in the memory. That worked. So then was the other Maru prompt. So now Maru remembered the name of the event, Stardew Valley Tech Conference, and later Maru actually started talking to Sebastian and spreading that idea to Sebastian. So Sebastian is now also interested in coming to that conference. And I also looked at the Pierre, and Pierre also heard about Jody's plans for that farming conference. I mean, it's a farming game, so everything from tech became a farming. Still, that was it. So this is the current stage of the simulation. I'm working now on kind of transferring it from Stardew Valley game to some kind of a real social live experiment, and seeing also if that can be used to imitate some social experiments or social behavior events. The technology which we used, Kafka, Flink, vector search, LLM, and here is the link to the resources which I mentioned, to the repository itself, and to the other research papers which I mentioned. And for those of you who are into Kafka, Flink, and Iceberg, we also have a certification completely free. If you want to test your knowledge and compare your knowledge to knowledge of other people, you can take this certification and also publish the badge later on your LinkedIn profile if you want to, show off with your knowledge. That's it from me. Thank you so much for listening.
We have one question. I'm going to give the microphone.
I'm not sure if you maybe mentioned that and I missed it or so, but as far as I understood, the conversations that are simulated right now are only between two people, or are there also conversations between like a group of people that are simulated?
No, only between two. I am actually, that was my initial simplification to just, because between three, I would need to adjust also at what point of time people enter and exit that multiple conversation. So this is still something I want to add, but at the moment there are like two people talking at a given moment.
Okay, thanks.
Any more? Sergey. Yeah, please use the microphone.
Yes, thank you. Are you using any techniques for like gradually forgetting what was in the previous conversation, like it happens with the like normal memory?
So this was my idea of summarizing the conversation, and this is actually where I think that it's indeed a good point, because it should be enough of the memory, some kind of detailed points, but not everything. And this is where I had to change that summary from being less detailed into being more detailed. Otherwise, it's very, very high level, and I cannot really spread the ideas between the characters. But yes, the summary is that mechanism for doing that. Yeah.
Thank you.
One question. So how do you come up with the personalities, initial personalities for the characters?
So that was personalities are taken from the game. They're taken from the game. There is a Wikipedia of Stardew Valley, and that was the part where I took actually all the information from the game, because it simplified for me so I could focus on the technical aspect instead of imagining the whole town. But right now, actually, what I want, that paper, for example, which I mentioned about simulating people based on their interviews, they do have a framework and in some examples of creating kind of personalities, and I want to use that instead of kind of copying Stardew Valley characters, because that would give me more like real people. So there is definitely, if you want to mimic some social situations, there is definitely research and available information on those traits and people which you can use. And there is, so there is even like proof that we could actually try to imitate, and it works with imitating the people. So, but for this particular one, it's all Stardew Valley. That's why they actually came up at the end. Like it was not a tech conference, but farming conference, which is still tech, but kind of, yeah.
Thanks so much.
We have 1 minute left. Anybody? Well, then there's a break. Thank you, Olena.
Thank
Please.
you. Thank you, everyone.